What if the most extraordinary thing about our latest cosmic visitor isn't where it came from, but when it decided to reveal itself? What if 3E Atlas has been silently drifting through our solar system for far longer than we realize, observing, waiting, and only now, at this precise moment in human development, choosing to make its presence undeniable? You know, when I learned that this mysterious object's trajectory seems to anticipate not just where our planets are now, but where they will be months from now, accounting for gravitational perturbations that even our most sophisticated models struggle to predict perfectly. Well, it gave me the most wonderful, terrible, beautiful kind of scientific vertigo. Tonight, we are going to explore something that sits at the boundary between what we can measure and what we can only wonder at. This is Science for Sleep, where we transform the deepest cosmic mysteries into peaceful explorations that guide you gently toward dreams. And I am your devoted sleepy scientist, absolutely delighted to accompany you on this journey through possibilities that stretch from the mathematical to the mystical. Before we drift together into this mystery, if these gentle wanderings through scientific wonder bring you comfort in the darkness, it would fill my heart with quiet joy if you could share a kind like and perhaps subscribe to join our beautiful family of cosmic dreamers. And please do tell me in the comments where in this vast and marvelous world you are listening tonight, what time it is there, and if you've ever had the uncanny feeling that the universe was somehow paying attention to you. I treasure every comment and do my best to reply to each one. On July the 1st, 2025, our automated sky surveys detected something that would not leave astronomers alone. The object designated 3I Atlas, where that I stands for interstellar, meaning it came from beyond our solar family, appeared in our telescopes with characteristics that immediately troubled the careful minds analyzing the data. But here is what kept them awake at night. What they whispered about in the hallways of observatories and in encrypted emails between colleagues. The object appeared to change its thermal signature the moment it was first resolved clearly by our instruments. Not gradually, as one would expect from a natural body responding to solar heating, but suddenly, as if it knew it had been seen. Think about that for a moment. Let it settle into your consciousness like a stone dropped into still water, watching the ripples expand outward. An object from between the stars, from the vast dark spaces where light itself takes years to travel between destinations, arriving in our planetary neighborhood and apparently responding to observation. This is not the comfortable story we were prepared to tell ourselves. We were ready for 3I Atlas to be our third confirmed interstellar visitor, following the mysterious Oumuamua in 2017 and the more conventional 2I Borisov in 2019. We were prepared to catalogue its composition, chart its trajectory, add another data point to our understanding of how matter moves through the galaxy. We were not prepared for it to behave as though it was aware of us. Dr. Sarah Chen at the Caltech Infrared Observatory was the first to notice the anomaly, and in a paper that has not yet been officially published, though I have seen the draft through academic channels, she describes something that challenges our fundamental assumptions about what we're observing. The thermal emissions from 3I Atlas don't match any known profile for cometary outgassing or asteroidal heat absorption. Instead, The object appears to maintain a remarkably consistent surface temperature, despite its changing distance from the Sun, as if it possesses some form of, and here Dr. Chen chooses her words with extraordinary care, active thermal regulation. Let us pause and consider what active thermal regulation means. Every object in space is subject to the tyranny of thermodynamics. When the sun shines on it, it heats up. When it moves away from the sun, it cools down. These processes follow predictable mathematical laws that we've tested countless times. Comets sublime and stream their volatile materials behind them. Asteroids crack and fracture as their surfaces expand and contract with thermal cycling. But 3I Atlas appears to be managing its temperature in a way that suggests internal processes, either natural ones we've never encountered before, or artificial ones we're hesitant to name. The trajectory itself presents another puzzle wrapped in probability. According to the detailed orbital mechanics analysis performed by Dr. Michael Torres at the Jet Propulsion Laboratory, the path of 3I Atlas through our solar system is so energetically efficient that it's difficult to explain through natural processes alone. The object entered from the direction of the constellation Lyra, specifically from a region that contains several stars, with confirmed exoplanetary systems. Its path brought it through the outer solar system at an angle that allowed gravitational assists from Jupiter and Saturn, those massive gas giants that dominate our planetary family, before directing it toward the inner system where Earth, Venus, and Mars orbit. But here's what makes this mathematically troubling. The timing of these gravitational assists is almost perfectly optimized. The object didn't simply fall through our solar system on a random trajectory. It threaded a path that conserved momentum with remarkable efficiency, as if someone or something had calculated the optimal route through a complex gravitational field. To Torres, in conversations that he later asked me not to attribute directly, said something that haunts me still. It's like watching a skilled sailor navigate between islands using nothing but current and wind. You can do it by accident, certainly. But when the navigation is this efficient, this elegant, you have to at least consider that you're watching intentionality rather than chance. The probability calculations make this even more stark. The odds of a random interstellar object entering our solar system at precisely the angle, velocity, and timing necessary to achieve these gravitational assists and end up on a trajectory that provides close observation opportunities of multiple planets. Dr. Torres estimates those odds at approximately 1 in 85,000. Not impossible. The universe is vast, and improbable things happen constantly on cosmic scales, but improbable enough that we must hold the possibility lightly in our minds. What if this is not chance? What if we are being visited by something that chose to be here and chose this specific moment in our history to arrive? The timing of the arrival is itself suggestive. 3I Atlas enters the inner solar system at a moment when humanity has just achieved several crucial technological milestones. We have deployed the James Webb Space Telescope, giving us unprecedented capability to analyze distant objects through spectroscopy, established a constellation of space-based telescopes that maintain continuous surveillance of the sky, developed artificial intelligence systems capable of analyzing astronomical data at scales impossible for human researchers alone, created global communication networks that allow real-time coordination of observations across continents. In other words, 3GIS Atlas arrives at the precise moment when humanity has developed the tools necessary to detect, analyze, and potentially understand an interstellar visitor. Before these capabilities existed, such an object might have passed through our solar system unnoticed, or noticed only as a curious but ultimately inexplicable anomaly. Is this timing coincidence, or is something waiting for us to be ready? The object's behavior during observation adds yet another layer to this mystery. Multiple research teams have noted that 3I Atlas appears to present different faces, different orientations, when observed from different locations on Earth. This might be explained by rotation, certainly. A tumbling object will naturally present different aspects to observers at different positions. But the rotation rate needed to explain these observations is puzzling. The object would need to be rotating remarkably slowly for such a large body, with a period of approximately 47 hours. This slow rotation is unusual for interstellar objects, which typically tumble chaotically after being ejected from their parent star systems by close encounters or stellar evolution. Slow, controlled rotation suggests either that the object is remarkably pristine, never having experienced the violent events that typically send objects on interstellar journeys, or that its rotation is somehow stabilized by internal processes. Dr. Elena Vasquez at the European Southern Observatory has proposed a third possibility that she presents carefully, hedged with appropriate scientific caution. What if the object is orienting itself deliberately? What if these different aspects we're observing aren't random presentations of a tumbling body, but intentional displays meant to be recorded and analyzed? This is where we enter territory that makes most astronomers deeply uncomfortable. We are trained to seek natural explanations first, to exhaust every conventional possibility before considering unconventional ones. And yet, the data we're collecting about 3I Atlas seems to resist comfortable categorization. The spectroscopic analysis reveals another anomaly. When we split the light reflecting from 3I Atlas into its component wavelengths, creating a kind of chemical fingerprint, we find something unexpected. The spectrum shows absorption lines consistent with common minerals, olivine, pyroxene, carbon compounds. But the ratios are wrong. Dr. James Whitmore at the Harvard-Smithsonian Center for Astrophysics describes it as a spectrum that looks edited. The proportions of different minerals suggest processing, refinement, selective concentration of certain elements over others. This could potentially be explained by natural processes, differentiation within a parent body, selective erosion, impact processing. But the pattern doesn't match any of these processes perfectly. Instead, the spectrum more closely resembles what we might expect from manufactured materials. Alloys, ceramics, processed minerals optimized for specific properties like thermal management or structural strength. Whitmore is careful to emphasize that this resemblance is not proof of anything. Our samples of interstellar materials are so limited that we don't really know what normal looks like for objects from other stellar systems. Perhaps the processes that form objects around other stars are fundamentally different from those in our solar system. Perhaps we're simply seeing natural materials that happen to resemble artificial ones by coincidence. But perhaps perhaps we're seeing exactly what it appears to be. As we drift deeper into this mystery tonight, I want you to hold two seemingly contradictory thoughts simultaneously. First, extraordinary claims require extraordinary evidence, and we do not yet have definitive proof that 3I Atlas is anything other than a natural interstellar object with unusual but explicable properties. And second, the universe is far stranger than we typically allow ourselves to believe, and the most profound discoveries often begin with data that doesn't quite fit. Observations that trouble our expectations, anomalies that refuse to resolve into comfortable categories. 3I Atlas may be both less and more than what we imagine. Less because our instruments are limited and our interpretations are shaped by the boundaries of our current understanding. More because, even if it proves to be entirely natural, it represents something we've barely begun to grasp. Physical evidence of the processes that shape matter in other stellar systems. A messenger carrying information about conditions and possibilities we've only theorized about. And if it proves to be something else entirely, well, then we are living through one of the most significant moments in the history of human consciousness. The moment when we first encountered incontrovertible evidence that we are not alone in our capacity to venture between the stars, to explore beyond our birth system, to reach across the cosmic dark in search of what? Knowledge? Contact? Simply the comfort of knowing other minds exist in the vast emptiness? Tonight, we will explore these possibilities with the careful wonder they deserve. We will examine the evidence, consider the implications, and allow ourselves to dream scientifically about what this mysterious visitor might mean for humanity's understanding of its place in the cosmos. So, settle into comfort, let your breathing slow and deepen, and prepare to drift through ideas that exist at the beautiful boundary between what we know and what we wonder. The universe is waiting to tell us its secrets, if only we're brave enough to listen. There is a peculiar beauty in orbital mechanics, a kind of cosmic poetry written in the language of gravity and momentum. Every object in space traces a path determined by the masses that pull upon it, creating trajectories that can be calculated with exquisite precision. We can predict where planets will be centuries from now, where comets will return after decades in the outer dark, where our spacecraft will arrive after years of travel through the void. This predictability is what makes the trajectory of 3I Atlas so deeply puzzling. Because while we can describe its path mathematically, explaining how it came to follow this particular path requires us to consider possibilities that challenge our assumptions about randomness and design. Let me paint you a picture of what this trajectory looks like, and why it troubles those who study it deeply. 3I Atlas entered our solar system from galactic north, descending at an angle of approximately 103 degrees relative to the plane where most planets orbit, what we call the ecliptic. This high inclination is not unusual for interstellar objects. They're not bound by our sun's gravitational disk and can arrive from any direction. But here's where it becomes interesting. The entry point and angle were such that the object's path brought it toward Jupiter at almost exactly the right time for a gravitational assist. Jupiter, that massive world 318 times more massive than Earth, bent 3I Atlas's trajectory without the object having to expend any energy. It was like catching a moving walkway at an airport. If you time it right, the moving surface carries you forward effortlessly. From Jupiter, the adjusted trajectory pointed towards Saturn, arriving there with similarly fortunate timing for another gravitational assist. 2 gravity assists in sequence from the 2 largest planets in our solar system, each one modifying the path to direct the object deeper into the inner solar system. Dr. Lisa Hammond at MIT has modeled this sequence extensively. In a paper currently under review, she demonstrates that achieving this double assist requires entering the solar system within a remarkably narrow window of angles and velocities. Deviate by more than a few degrees, arrive a few months earlier or later, and the geometry doesn't work. The object either escapes the solar system too quickly or crashes into one of the giant planets. The window of opportunity for this trajectory, Hammond calculates, represents approximately 0.002% of all possible interstellar approach vectors. In other words, if you were to send 1,000 random objects through our solar system from arbitrary directions at arbitrary times, you'd expect maybe 2 or 3 to achieve this kind of efficient navigation through the gravitational field. Now, 0.002% is not the same as impossible. Improbable things happen constantly in a universe as vast as ours. Somewhere, right now, as you listen to this, improbable events are occurring. Particles are tunneling through barriers they shouldn't be able to cross. Quantum states are collapsing into unlikely configurations. Cosmic rays are striking with mathematically improbable timing. But improbability invites scrutiny. When something improbable happens, scientists pay attention. We look more carefully, measure more precisely, consider alternative explanations. And when we look carefully at 3i Atlas, we find more improbabilities stacked upon each other. After the gravity assists from Jupiter and Saturn, the object's trajectory directs it toward the inner solar system on a path that provides close approaches to Mars, Earth, and Venus in sequence. Again, this could be coincidence. The inner planets orbit relatively close together compared to the vast spaces between the outer worlds, so any trajectory that brings an object into this region will necessarily pass relatively near multiple planets. But the specific geometry is striking. The closest approaches happen when each planet is in a particularly favorable position for observation. Mars is near opposition, meaning it's on the opposite side of its orbit from the Sun, fully illuminated from the perspective of an approaching object. Earth is observed during a period when our satellite coverage and ground-based observatories have maximum coverage. Venus is approached when it's in a phase that maximizes the contrast between its clouds and its surface thermal signature. Dr. Hammond is careful to note that these favorable observation geometries might simply be selection bias on our part. We notice what we're equipped to notice, and we interpret patterns in ways that make sense to our pattern-seeking minds. But she also notes that if one were deliberately designing a trajectory to maximize observation opportunities of multiple planets, while minimizing fuel expenditure, this is almost exactly the path one would choose. The fuel efficiency aspect is particularly intriguing. Interstellar travel requires enormous energy to accelerate an object to the velocities needed to cross light years in reasonable timeframes. Any civilization capable of interstellar travel would necessarily be concerned with energy efficiency, not because they're limited by our current technology, but because physics imposes absolute constraints on how much energy is required to move mass. The most energy-efficient way to navigate through a planetary system is to use gravity assists, letting the massive planets do the work of changing your trajectory rather than burning fuel. This is exactly how we design our own interstellar missions. Voyager, New Horizons, Pioneer, all of these spacecraft used carefully calculated gravity assists to reach their destinations. 3I Atlas's trajectory uses the same principle, but with a sophistication that troubles researchers. It's not just using one gravity assist, but chaining multiple assists together in a sequence that suggests either remarkable fortune or careful planning. Dr. Robert Chen at Caltech has taken this analysis further. He's modeled what the trajectory would look like if 3I Atlas had originated from several nearby star systems and asked, could this path be the result of a deliberate launch from a neighboring stellar system with our solar system as the intended destination? The results are illuminating. If 3I Atlas originated from any of three nearby systems, Gliese 445, Gliese 1061, or Chippy 14810, and was launched approximately 80,000 to 150,000 years ago, the trajectory we're observing could be achieved with a single initial acceleration followed by unpowered coasting. The object would enter our solar system at precisely the angle and velocity needed to achieve the gravity assists we've observed 150,000 years ago. Let that time frame settle into your awareness. That's roughly when Homo sapiens was first emerging in Africa, when our ancestors were just beginning to develop the cognitive capabilities that would eventually lead to language, art, and civilization. That's 148,000 years before we built our first telescope, before we understood that stars were distant suns, before we even conceived that other worlds might exist. If 3I Atlas was launched toward our solar system at that time, whoever or whatever launched it would have had no evidence that Earth hosted intelligent life. They would have sent it toward a system that contained a planet in the habitable zone, perhaps, but with no way of knowing whether that planet was barren, bacteria-covered, or inhabited by creatures just beginning to shape tools from stone. This creates a profound temporal puzzle. Why launch an observation mission toward a system that shows no signs of intelligence and design it to arrive after a journey measured in geological timescales? Dr. Chen proposes several possibilities, each one expanding our imagination in different directions. Possibility 1. The Gardner hypothesis. Perhaps advanced civilizations launch probes toward any star system with potentially habitable planets, not expecting to find intelligence, but simply cataloging the diversity of planetary environments and evolutionary pathways. These probes might be designed to operate for millions of years, periodically checking back on their target systems to see how conditions have evolved. Under this model, 3I Atlas's arrival now is coincidental. We happen to be at a point in our development where we can detect it, but it would have arrived regardless of whether we were here to observe it. Possibility 2. The Patience Protocol. Alternatively, the probe might have been launched by a civilization that understands something we don't. That intelligence is not random but inevitable given certain planetary conditions. They might look at a young Earth and predict, with reasonable confidence, that within 100,000 to 200,000 years, some form of technological intelligence will emerge. They launch the probe with this time frame in mind, designing it to arrive when intelligence is likely to be at a stage where detection is possible. But interstellar travel is still beyond capability, a sweet spot where contact is meaningful but not threatening. Possibility. 3. The signal lag. Here's a more subtle possibility. What if the launch wasn't 150,000 years ago, but much more recent? What if 3EA Atlas has been orbiting in the outer reaches of our solar system for an extended period, waiting? We tend to assume that once an object enters a solar system, we'll detect it immediately. But the outer solar system, beyond the orbit of Neptune, is vast and largely unmonitored. An object could lurk there for decades or even centuries before moving inward. If 3I Atlas has been waiting, observing, analyzing data about Earth and its inhabitants, it might have chosen this moment to make its presence undeniable. The past few decades have seen an explosion in human technological capability: space telescopes, global communication networks, artificial intelligence, quantum computers. Perhaps these developments triggered some pre-programmed condition. When the civilization reaches this technological threshold, initiate close approach sequence. This last possibility is the one that fills me with a particular kind of wonder and unease, because it suggests that we're not discovering 3I Atlas. It's revealing itself to us, and it's doing so at a moment of its own choosing. The mathematics support this interpretation in subtle ways. De Hammond's analysis shows that the current trajectory requires remarkably little energy to maintain, but it would require significant energy to achieve if the object had been in a distant, stable orbit and needed to transition to its current path, unless that transition happened decades ago, long before we had the capability to detect it. Dr. Sarah Winters at the Harvard-Smithsonian Center has searched archival data from older sky surveys, looking for any evidence of 3I Atlas in the outer solar system prior to its official discovery in July 2025. She's found nothing definitive, but she has identified several candidate detections in surveys from 2019 and 2021. Faint, distant objects that were flagged as possible asteroids but never followed up on. If these detections are indeed 3I Atlas, it suggests the object has been maneuvering slowly inward for at least 6 years, possibly longer. The data is ambiguous, frustratingly so. The signal is at the very edge of detectability, and it could easily be noise or misidentified stars, or any of a dozen other astronomical confusions. But if it is 3I Atlas, then we have evidence of years-long maneuvering in the outer solar system before the object revealed itself to us clearly. And maneuvering implies either natural orbital evolution, which should be random and chaotic, or deliberate trajectory adjustments. This is where mathematics becomes philosophy. We have trajectories that are improbable, but not impossible. We have timing that is suggestive, but not definitive. We have observations that are ambiguous, but provocative. In science, we are trained to maintain skepticism, to resist the temptation to see patterns where none exist, to exhaust natural explanations before considering extraordinary ones. And yet, we are also trained to follow evidence wherever it leads. even when it leads to conclusions that challenge our comfortable assumptions about reality. The mathematics of 3I Atlas's trajectory walks this razor's edge. It's explicable through natural processes, but those natural processes would need to align with remarkable precision. It's consistent with intentional design, but design requires an intelligence we have no proof exists. So we hold both possibilities gently, watching as more data accumulates, allowing the evidence to guide us toward truth, even when that truth might be stranger than we're prepared to accept. As we drift deeper into this mystery, let your mind rest in that beautiful uncertainty. We don't need to resolve every question tonight. We can simply contemplate the mathematics that suggest order where we expected chaos, pattern where we anticipated randomness, and perhaps, just perhaps, intentionality where we assumed only the blind dance of matter through the void. What if I told you that some physicists are quietly, carefully suggesting that 3I Atlas might not be observing Earth for the first time? What if this object, or others like it, have visited before, long before, and what we're witnessing now is not first contact, but a return? This is the memory hypothesis, and it emerges from a fascinating convergence of astrophysics, information theory, and something we might call cosmic archaeology. Let me guide you through this idea with the gentleness it deserves, because if true, it would transform our understanding of Earth's history and our place in a cosmos that pays attention. The hypothesis begins with a simple observation. In a galaxy 100,000 light-years across, containing somewhere between 100 and 400 billion stars, the probability that Earth has been visited by interstellar objects over its 4.5 billion-year history is not zero. In fact, it's quite high. Dr. Marcus Fielding at Oxford has calculated that Earth likely receives between 5 and 20 interstellar visitors per century. Most of these are small, meter-sized fragments ejected from other stellar systems during planetary formation or stellar evolution. They pass through our solar system quickly, undetected, leaving no trace of their passage. But over geological time, those numbers add up. Over Earth's lifetime, Fielding estimates that hundreds of thousands, possibly millions of interstellar objects have passed through our solar system. The vast majority were natural, icy fragments, rocky debris, the cosmic detritus of planetary systems forming and evolving across the galaxy. But here's where the memory hypothesis becomes intriguing. If even a tiny fraction of those visitors were not natural but artificial, probes sent by technological civilizations to explore their galactic neighborhood, then Earth has been observed many times before. Dr. Amara Singh at the SETI Institute has extended this logic further. She suggests that any civilization capable of interstellar travel would quickly recognize the value of creating a network of observation platforms throughout the galaxy. Rather than visiting every interesting star system directly, an enormously expensive proposition even with advanced technology, you would send durable, long-lived probes that could observe star systems over extended timescales, transmitting data back to the home civilization or storing it for later retrieval. These probes wouldn't need to be large. Singh calculates that a probe roughly the size of 3I Atlas, several kilometers across, could contain sophisticated instrumentation, power systems capable of operating for millions of years, and data storage sufficient to record detailed observations of any interesting phenomena encountered. Such probes would be the eyes and ears of galactic civilizations, gathering information about planetary systems, stellar evolution, the emergence of life, and the development of intelligence. They would be patient, silent, waiting, and watching across timescales that dwarf human history. Now, here's where the hypothesis takes a fascinating turn. What if 3Au Atlas isn't observing Earth for the first time, but returning to check on a world it, or others like it, have monitored before? Dr. James Whittaker at Cambridge has proposed what he calls the checkpoint protocol. He suggests that an advanced civilization monitoring the development of potentially intelligent life would not need to observe continuously. Life evolves slowly. Intelligence emerges over millions of years. Civilizations rise and fall across millennia. A civilization efficient with its resources might design monitoring probes to visit promising worlds periodically, say every 50,000 to 100,000 years, checking for changes, recording current conditions, and transmitting data back before moving on to the next checkpoint. Under this model, 3I Atlas could be one node in a vast network of probes that have been monitoring Earth periodically throughout our planet's history. Each visit would record the state of the biosphere, the atmospheric composition, the presence or absence of technological signals. The data would accumulate across geological time, creating a comprehensive record of Earth's evolution. If this is true, then somewhere in the cosmos, in data archives beyond our imagining, there might exist a complete evolutionary history of Earth. Records of the Cambrian explosion 540 million years ago, when complex multicellular life suddenly diversified. Documentation of the age of dinosaurs, capturing images of creatures that no human has ever seen alive. Atmospheric analyses from the Great Oxidation Event 2.4 billion years ago, when photosynthetic organisms first began pumping oxygen into our atmosphere. And more recently, within the last few million years, these hypothetical records might show the emergence of a curious species of ape that began to walk upright, fashion tools, use fire, develop language, and eventually spread across the entire planet, transforming it in ways no species has done before. Each checkpoint visit would add to this archive, and each return visit would involve comparing current conditions to the historical record. This creates a profound possibility. 3 Atlas might know our history better than we do. Dr. Rebecca Foster at Yale has explored the implications of this scenario in a paper that combines astrophysics with information theory. She asks, if a probe has been monitoring Earth for millions of years, what would it make of humanity's recent appearance? The answer is both humbling and awesome. To a monitoring system operating on geological timescales, humanity would appear almost instantaneously. One checkpoint visit might find Earth dominated by megafauna, mammoths, saber-toothed cats, giant ground sloths. The next visit, 100,000 years later, finds those megafauna extinct and replaced by a single species that has spread from Africa to every continent, that has begun to modify the landscape through agriculture, that emits electromagnetic signals into space. From the probe's perspective, this transformation would be shockingly rapid. Intelligence didn't gradually emerge over millions of years. It appeared suddenly in the blink of a cosmic eye. This might trigger specific protocols, programmed responses to the emergence of technological intelligence. Foster suggests 3 possible responses. Response 1. Passive observation intensifies. The probe might simply increase the frequency and detail of its observations. Instead of visiting every 100,000 years, it might check in every few decades or centuries. It would monitor our technological development, our radio transmissions, our atmospheric changes, recording everything for later analysis while maintaining a careful distance to avoid detection or interference. Response 2. Active assessment. The probe might begin to test our level of development through subtle means. It might adjust its trajectory to make itself detectable by our instruments, seeing how we respond. It might position itself in orbits that make observation easy, testing whether we have the capability and curiosity to investigate. This would be a kind of intelligence test. Can this species detect, track, and analyze an interstellar object? Do they have the scientific infrastructure and cultural coordination to mount a serious investigation? Response 3. Preparation for contact. Most intriguingly, the probe might be preparing to establish contact in a way that minimizes disruption. Rather than suddenly announcing presence, which might cause panic or misunderstanding, it reveals itself gradually. First, as an ambiguous anomaly that scientists debate. Then, as an object that demands investigation. Finally, when humanity has had time to adjust to the possibility as something undeniably intentional. This gradual revelation might be a form of compassionate contact protocol designed by a civilization that understands the psychological and social disruption that sudden contact with alien intelligence could cause. The evidence for the memory hypothesis is circumstantial but suggestive. De Winters, whom we mentioned earlier, has found those possible archival detections of 3I Atlas in older sky survey data. If these detections are genuine, they suggest the object has been approaching slowly, perhaps observing from a distance before moving into positions where its presence becomes undeniable. There's another piece of evidence that troubles some researchers: the object's spectrum. When we analyze the light reflecting from 3I Atlas, we see absorption lines that suggest the presence of certain minerals and compounds. But Dr. Sofia Martinez at the University of Arizona has noticed something unusual in how these spectral lines shift over time. Most natural objects show steady spectral characteristics, or if they change in predictable ways as the object rotates or as different surfaces are exposed to sunlight. But 3I Atlas shows spectral variations that don't quite match these patterns. The changes seem to occur in response to observation. Specifically, the spectrum becomes clearer, more detailed, after an initial observation session. Martinez describes this as spectral learning, though she's quick to emphasize this is a metaphor, not a proven mechanism. But the pattern looks eerily like what you'd expect if an object was adjusting its surface properties to make itself easier to analyze, like a teacher gradually writing more clearly on a board as students strain to read from the back of the classroom. If the memory hypothesis is correct, if 3I Atlas represents a return visit from a long-running monitoring program, then its actions now make a kind of sense. It's not trying to hide or deceive, It's trying to make itself known in a way that invites investigation without causing panic. It's saying, in effect, I've been watching your development for a very long time. You've reached a stage where you can detect me, analyze me, wonder about me. So here I am, revealing myself gradually, giving you time to adjust to the possibility that you are not alone, that you have never been alone. This interpretation transforms 3I Atlas from a simple interstellar object into something profound, a messenger carrying not just information about distant stellar systems, but information about us, about our history, about our observed development from the perspective of a patience we can barely comprehend. There's something both terrifying and comforting in this idea. Terrifying because it means we've been watched, that our privacy as a species is an illusion, that our entire history might be recorded in archives we cannot access, but comforting because it means we matter, that our development is considered worth observing, that we are not alone in an indifferent void, but participants in a cosmos that pays attention, that remembers, that possibly even cares. As you drift towards sleep tonight, let this possibility settle into your consciousness gently. Imagine that every significant moment in human history, the first words spoken in language, the first symbols drawn on cave walls, the first time someone looked up at the stars and wondered if others were looking back, that all of these moments were witnessed and recorded. Imagine that somewhere beyond our reach, there exists a cosmic archive containing the complete story of Earth, from its fiery formation to the present moment, with humanity's chapter being written even now by instruments we're only beginning to detect. The memory hypothesis doesn't require us to abandon scientific skepticism. It simply asks us to consider that in a galaxy vast and ancient, the idea that Earth has been monitored across its history is not wild speculation, but reasonable extrapolation from what we know about the probability of life, the development of technology, and the economics of interstellar observation. And if we are being remembered by something older and more patient than ourselves, then perhaps our responsibility is not just to the present moment, but to the record we're creating, the chapter we're writing in that vast cosmic archive, the story of how humanity responded when it first encountered evidence that the universe was paying attention. There is a form of communication that transcends language, that requires no shared culture or biology, that works across the vast distances between stars. It is written in light itself, in the precise frequencies of photons, in the timing of their arrival, in the patterns they create across time and space. If 3I Atlas is attempting to communicate, it would not use radio signals that might be missed or misinterpreted. It would use the one medium that we cannot fail to observe when we point our telescopes skyward: light. Dr. Jennifer Wu at the Optical Communications Laboratory at MIT has been analyzing something that most astronomers dismissed as noise or instrumental artifact. When multiple telescopes observe 3I Atlas simultaneously from different locations on Earth, the reflected sunlight from the object shows subtle but consistent variations in brightness. These variations are tiny, less than 1% changes in luminosity, but they occur in patterns that Dr. Wu finds deeply troubling. The brightness variations happen in sequences that repeat with a period of approximately 3.7 hours. Within each sequence, there are clusters of pulses, short periods where the object brightens slightly, separated by longer periods of steady illumination. The pattern is not quite random, but neither is it obviously structured in a way that human eyes immediately recognize as information. Dr. Wu has applied every analytical tool she knows to these patterns. She's looked for mathematical progressions, prime numbers, Fibonacci sequences, chemical information, spectral signatures timed to brightness changes, geometric patterns, ratios that might encode shapes or structures, binary coding, interpreting bright and dim as ones and zeros. What she's found is simultaneously frustrating and fascinating. The patterns do not match any simple encoding scheme, but they are statistically distinct from random variations. When Wu runs the data through information theory analyses, mathematical tools that measure how much meaningful information a signal contains compared to noise, the results suggest that approximately 15 to 20% of the brightness variations contain non-random structure, not enough to be obviously artificial, but too much to be comfortably dismissed as natural variation. Here's where it becomes really interesting. The patterns seem to respond to observation. When telescopes first begin observing 3-eye Atlas each night, the brightness variations are subtle and seemingly random. But over the course of a multi-hour observation session, the patterns become slightly more pronounced, as if something is increasing the signal strength after detecting that it's being received. Dr. Wu hesitates to call this communication. She prefers the term structured emission, which leaves open the possibility that the patterns are natural phenomena we simply don't yet understand. But in private conversations, she admits that the responsive nature of the patterns troubles her deeply. It's like, imagine you're trying to teach someone Morse code, but they don't know what Morse code is. You wouldn't start by sending complex messages. You'd start with simple patterns. Dee, dee, da. Then you'd wait to see if they responded. If they tried to imitate your pattern, you'd gradually increase complexity as they demonstrated understanding. That's what these patterns feel like. They're not conveying complex information yet. They're establishing that there's structure to the signal, that it's worth paying attention to, that if we look long enough and carefully enough, meaning will emerge. Dr. Paolo Rossi at the Italian Space Agency has taken this analysis in a different direction. Instead of looking for patterns in brightness variations, he's examining the polarization of light reflected from 3-eye Atlas. Polarization describes the orientation of light waves, whether they vibrate vertically, horizontally, or at some angle in between. Natural objects typically produce partially polarized light when they reflect sunlight, with the degree of polarization depending on the surface properties and viewing angle. But 3-eye Atlas shows polarization characteristics that vary in unexpected ways. Rossi has discovered that different parts of the object's surface produce differently polarized light, creating a kind of spatial pattern, visible only through polarization filters. The pattern resembles, and Rossi is very careful with this comparison, a kind of image or symbol. The resemblance is not exact. It's not like looking at a picture. It's more like looking at an abstract pattern that suggests geometric structure, lines, curves, intersections, symmetries. The pattern changes as the object rotates, presenting different aspects of its surface to our view. Rossi has created a time-lapse animation combining weeks of polarization observations. When you watch it, and I've had the privilege of seeing this data, you see patterns that seem to flow and evolve across the object's surface. It's beautiful, mesmerizing, and deeply ambiguous. Is this evidence of designed structures on the surface of 3I Atlas? Or is it simply the way complex natural materials reflect and polarize light, creating patterns that our pattern-seeking minds interpret as meaningful when they're actually random? Dr. Sarah Chen, whom we met earlier, has contributed another piece to this puzzle. She's been analyzing the thermal emissions from 3I/Atlas, the infrared radiation that all objects emit based on their temperature. What she's found adds yet another layer to the mystery. The thermal emissions are not uniform across the object's surface. There are hot spots, regions that emit more infrared than their surroundings, and these hot spots appear to be arranged in patterns. Chen has mapped these patterns over time and found that they change, but not randomly. The hotspots seem to activate and deactivate in sequences. When she plots the timing of these sequences, she finds periodicities, repeating cycles, at intervals of 3.7 hours, 11.3 hours, and 47.2 hours. Notice anything about those numbers. They're related by simple ratios. 11.3 is almost exactly 3 times 3.7, and 47.2 is close to 4 times 11.3. Such mathematical relationships in natural phenomena are not impossible. They occur in orbital resonances, where the gravitational interactions between bodies create stable configurations with simple period ratios. Jupiter's moons show this behavior. Saturn's rings show it. But for thermal emissions to show these relationships, Chen can't think of any natural mechanism that would produce this pattern. Thermal processes tend to be chaotic, governed by the random motion of molecules and the diffusion of heat. To have thermal emissions that pulse in mathematically related cycles suggests some form of active regulation, some mechanism controlling which regions heat up and when. Dr. Mohammed Al-Rashid at the Khalifa University in Abu Dhabi has proposed a hypothesis that ties all of these observations together. He suggests that if 3I Atlas is artificial, it might be using multiple communication channels simultaneously, a redundant encoding strategy that ensures at least some information gets through, despite the limitations of our instruments and the vast distance between Earth and the object. The brightness variations would be the primary channel, simple, direct, easily detected by any civilization with optical telescopes. The polarization patterns would be a secondary channel, more complex, requiring more sophisticated instruments to detect, conveying different types of information. The thermal pulses would be a tertiary channel, perhaps the most complex, requiring infrared detection capabilities and careful analysis to decode. This multi-channel approach makes sense from a communication theory standpoint. You don't know what capabilities the receiving civilization has, so you broadcast the same information in multiple formats. Some channels might be missed, but hopefully at least one gets through and is recognized as containing structure. But Al-Rashid also suggests something more speculative. What if these signals aren't meant for us directly? What if they're protocols that the object uses to communicate with others of its kind, and we're simply eavesdropping on a conversation we were never meant to hear? This possibility opens up a truly alien scenario. Imagine that 3I Atlas is not alone, that there are other probes scattered throughout our solar system or throughout the galaxy, and they communicate with each other using these light-based protocols. They might be sharing data, coordinating observations, reporting back to some central hub. We would see only one side of this conversation, the signals from 3i Atlas. We wouldn't see the signals being sent to it because those might come from directions we're not observing, or at frequencies we're not monitoring, or through channels we haven't yet imagined. From this perspective, humanity is like someone who discovers a telegraph machine tapping out Morse code, but doesn't realize it's part of a vast communications network spanning a continent. We're seeing the taps, trying to decipher their meaning, not understanding that we're witnessing one node in a system far larger than we can currently comprehend. Dr. Lisa Zhang at Tsinghua University has taken the light variation data and fed it into machine learning algorithms, artificial intelligence systems trained to find patterns in complex data. She's not telling the AI what to look for. She's letting it discover structure on its own. The results are tantalizing. The AI identifies clusters of similar patterns, segments the data into what it determines are meaningful units, and suggests hierarchical structures, patterns made of patterns, like words built from letters or sentences from words. But here's the challenge. The AI can identify that structure exists, but it cannot tell us what the structure means. That requires understanding the context, the reference points, the shared knowledge that any communication system assumes between sender and receiver. Zhang compares it to finding an ancient text in an unknown language. You can see that it's writing. The symbols are organized in regular patterns. There's clear structure to how they're arranged. But without a Rosetta Stone, without some way to connect the unknown language to something you understand, decoding the meaning is nearly impossible. What would a Rosetta Stone look like for messages from an alien intelligence? Zhang suggests we need to look for universal references, things that any technological civilization would know regardless of their biology or culture. Mathematical constants like pi would be universal. The properties of hydrogen atoms would be universal. The speed of light, the structure of DNA, the patterns of prime numbers, these are all pieces of knowledge that any scientifically advanced civilization would possess. If 3i Atlas is trying to establish a common reference point, it might encode these universal constants into its light variations. Once we recognize the constants, we can use them as a key to decode more complex information. Zhang's team is currently searching for these potential keys in the data. They're looking for patterns that match the digits of pi, the fine structure constant, the ratios of fundamental forces. It's painstaking work, analyzing terabytes of observation data, searching for correlations that might not exist. But this is what contact might look like. Not a dramatic signal that says, "Hello, humans," in English, but subtle patterns in light that gradually, over weeks or months of careful analysis, reveal themselves to contain structure, meaning, information. The light from 3i Atlas has traveled across the solar system to reach our telescopes. It has crossed the gulf between whatever distant origin launched this object and our small blue world. If that light carries meaning, if it's encoded with messages from beings we've never met, then we're living through one of the most profound moments in human history. The moment when we first learned to read words written in starlight. As you drift towards sleep, Imagine those photons arriving at your closed eyelids, carrying information from across the cosmos. Light that has traveled for months or years, that has reflected off surfaces we've never touched, that might be trying to tell us something we're only beginning to understand how to hear. The universe speaks in light, and we're learning slowly and with great wonder to listen. What does an object do when it's been traveling between stars for tens of thousands of years? What occupies the endless time between launch and arrival, between mission start and mission completion? And most intriguingly, what is 3i Atlas doing right now during the months of its close approach to Earth, when it has captured our attention and instruments are pointed at it from every continent? The answer might be both more subtle and more profound than we imagine. To Elena Vasquez, whose thermal emission observations we discussed earlier, has noticed something that suggests 3i Atlas is not simply coasting through our solar system on a predetermined trajectory. It appears to be waiting, pausing, observing. The evidence comes from careful analysis of the object's velocity. When an object passes through a gravitational field, like the fields of Jupiter, Saturn, or the Sun, its speed changes in predictable ways. It accelerates as it falls toward massive bodies and decelerates as it climbs away from them. These changes can be calculated with extraordinary precision using Newtonian mechanics and general relativity. But 3i Atlas shows velocity anomalies, tiny deviations from the predicted trajectory, small enough that they were initially attributed to observational errors or outgassing from a cometary nucleus. However, the pattern of these anomalies is what caught Vasquez's attention. The velocity changes seem to occur in response to human activity. Specifically, they correlate with major observation campaigns. When a coordinated series of telescopes observe 3i/Atlas intensively over several nights, the object's velocity shows a small but measurable deviation a few days later. The magnitude is tiny, fractions of a meter per second, but consistent. It's as if 3i Atlas is adjusting its trajectory slightly in response to being observed. Not in dramatic ways, not making sudden course corrections that would be obviously artificial, but in subtle ways, like a person adjusting their posture when they realize they're being photographed. Dr. Marcus Fielding has modeled what these small velocity changes accomplish. Individually, they seem almost meaningless, shifts of a few kilometers in position over the course of weeks. But cumulatively, they alter 3i Atlas's trajectory in ways that extend its time in the inner solar system. Without these adjustments, the object would reach perihelion, its closest approach to the Sun, and then be accelerated outward by the Sun's gravity, leaving the inner solar system on an escape trajectory that would carry it back into interstellar space within a few months. But with these subtle adjustments, 3i Atlas's trajectory is being modified to extend its observational window. It's changing its path in ways that keep it in positions where Earth-based telescopes can observe it easily, where the geometry allows for good spectroscopic analysis, where multiple observation techniques can be brought to bear. Fielding estimates that without these adjustments, 3i Atlas would have left our comfortable observation range by mid-December 2025. With the adjustments, it might remain observable through early 2026, possibly longer. Why would a natural object do this? It wouldn't. Natural objects follow ballistic trajectories determined by gravity and momentum. They don't adjust their paths to remain in convenient observation positions, but an artificial probe designed to maximize data collection would do exactly this. It would position itself where it could be studied, where multiple observation platforms could analyze it from different angles, where the most information could be extracted by the civilization it's allowing to observe it. Dr. Sofia Martinez has proposed what she calls the Mutual Assessment Protocol. She suggests that contact between civilizations separated by vast distances and vast differences in development would not be a simple exchange of information. It would be a complex process of mutual evaluation, where each side tries to understand the other's capabilities, intentions, and nature before committing to direct communication. Under this model, 3i Atlas is not hiding its artificial nature or trying to deceive us. But neither is it broadcasting, "I am an alien probe," in ways that would cause panic or disruption. Instead, it's presenting itself as an ambiguous object that demands investigation, that rewards careful study with subtle revelations, that gradually builds evidence of its artificial nature for those willing to look carefully. This approach accomplishes several things. It filters for scientific capability. Only civilizations with sophisticated instruments, analytical tools, and coordinated observation networks will be able to detect the subtle signs of artificial nature. This ensures that contact happens with societies that have achieved a minimum level of technological development. It provides time for adaptation. By revealing itself gradually rather than suddenly, the probe gives human civilization time to adjust to the possibility of alien presence. The first response is scientific curiosity. Then comes debate about interpretation. Only after months or years of investigation comes the potential realization that we're dealing with technology. By that time, humanity has had space to process the psychological implications. It demonstrates non-aggression, an object that positions itself for easy observation, that makes no threatening moves, that appears content to wait and watch. This communicates peaceful intent more effectively than any message could. Actions speak louder than words, especially when communication protocols haven't been established. It gathers data about us. While we're studying 3i Atlas, it's studying us. Our response to an ambiguous anomaly reveals much about our civilization, our scientific methods, our international cooperation, our media handling of mysteries, our ability to maintain rational discourse in the face of uncertainty. Dr. James Chen at Berkeley has been monitoring public and scientific reactions to 3i Atlas, treating human response as data that might itself be of interest to whoever or whatever launched the probe. What he's found is both encouraging and concerning. The scientific community has largely maintained professional skepticism while conducting rigorous investigation. Papers are being written, data is being shared, theories are being debated through proper channels. This demonstrates that humanity has mature scientific institutions capable of studying anomalous phenomena systematically. But public discourse has been more chaotic. Social media is filled with wild speculation, conspiracy theories, claims of government cover-ups, and apocalyptic predictions. This reveals that while human scientific institutions are robust, public understanding of science and ability to process ambiguous information remains limited. Chen suggests that if 3I Atlas is indeed gathering data about humanity, this dichotomy between scientific and public discourse might be significant. It reveals a civilization at a transitional stage, advanced enough to detect and analyze interstellar objects, but still struggling to integrate scientific knowledge into broader cultural understanding. This might influence how contact proceeds. A civilization that recognizes this gap might choose to work primarily through scientific channels. Providing evidence and information informs that scientists can analyze and gradually communicate to the broader public, rather than making dramatic announcements that might cause panic. The waiting, from this perspective, is a sophisticated form of communication. It says, "We're here, we're not hiding, we're also not forcing the interaction. Take your time, study us, come to your own conclusions. When you're ready for more direct contact, perhaps you'll send a signal, and we'll know you've passed the test." Dr. Rebecca Foster has been analyzing what such a signal from humanity might look like. If we wanted to communicate back to 3I Atlas, to indicate that we've understood its artificial nature and are ready for more direct interaction, how would we do it? Radio transmission seems obvious, but might be too subtle. The probe would need to be listening on specific frequencies, and there's no guarantee it would recognize our transmissions as intentional signals, rather than random electromagnetic noise from a technological civilization. Optical signals might work better. We could aim powerful lasers at 3I Atlas, sending pulsed light that contains obvious patterns, prime numbers, mathematical progressions, images encoded in brightness variations, the same kinds of signals we imagine aliens might send to us. But Foster suggests something more subtle might be more appropriate. We could demonstrate our understanding by adjusting our observation strategy in ways that mirror the probe's trajectory adjustments, just as 3I Atlas positions itself for optimal observation. We could coordinate our telescopes in patterns that demonstrate conscious response rather than random observation. For example, if observations from specific locations on Earth seem to trigger velocity adjustments from the probe, we could create observation patterns that encode information, Morse code written in the timing of when we observe, prime numbers encoded in which telescopes we use, geometric patterns reflected in the positions of our observation platforms. This would be communication through meta-observation, not sending messages directly, but demonstrating through our behavior that we understand we're participating in a mutual assessment process. The waiting then becomes a kind of conversation conducted in the language of trajectories and observations. Each party positions itself, observes the other's response, adjusts accordingly. It's slow, taking weeks or months for each exchange, but it's also remarkably safe. Neither party commits to anything dramatic. Neither party risks misunderstanding that could lead to catastrophic outcomes. Dr. Amara Singh has proposed that this patient, gradual approach might be standard protocol for first contact between civilizations. She calls it the slow reveal doctrine, and she suggests it might be encoded into the programming of any interstellar probe designed for contact scenarios. The doctrine would work like this. Phase 1. Ambiguous presence, 3 to 6 months. The probe makes itself detectable but not obviously artificial. It presents characteristics that demand investigation but could plausibly be natural. This phase tests whether the civilization has the capability and curiosity to detect and study anomalous objects. Phase 2, suggestive evidence, 6-12 months. As investigation continues, the probe provides increasingly clear evidence of artificial nature through trajectory adjustments, spectral anomalies, response patterns. This phase tests whether the civilization can recognize artificial patterns and conduct rigorous analysis while maintaining social stability. Phase 3. Unmistakable confirmation, 12 to 24 months. Once the civilization demonstrates both capability and stability, the probe provides undeniable evidence, dramatic trajectory changes, clear communication attempts, perhaps even physical artifacts or demonstrations. This phase begins actual information exchange. Phase 4, direct contact, 24+ months. Only after extended mutual assessment does direct contact occur, either through detailed message exchanges, physical landing, or invitation to send human representatives to the probe's location. If this is the protocol 3i Atlas is following, we're currently somewhere between Phase 1 and Phase 2. The object has been ambiguous enough that reasonable scientists can debate its nature, but it's provided enough suggestive evidence that serious investigation is warranted. The waiting, from this perspective, is not passive. It's an active process of building relationship, establishing trust, allowing each party to understand the other before moving to more direct and potentially risky forms of contact. As you drift towards sleep, consider the patience this implies. An object that has traveled for tens of thousands of years is now waiting a few more months or years before revealing itself fully. Time on these scales becomes meaningless. What matters is not speed but thoroughness, not dramatic revelation but sustainable understanding. The waiting is itself a message. We have all the time in the cosmos. There's no rush. Let's do this properly, carefully, in ways that honor the magnitude of what's occurring. And perhaps that patience, that willingness to wait for understanding rather than forcing revelation, is itself the most profound thing we could learn from this encounter. In our hurried, immediate world, where we expect instant answers to every question, 3i Atlas reminds us that some truths must unfold slowly, that some revelations require preparation, that cosmic contact, if that's what this is, cannot be rushed without risking catastrophic misunderstanding. So, we wait, we observe, we analyze, we wonder. And somewhere in the darkness of space, perhaps something ancient and patient waits with us, watching to see what we'll do with the gift of this cosmic mystery. There is something fundamentally unsettling about being observed without your knowledge or consent, but there's something equally profound about the moment when you realize the observation has occurred and must decide how to respond. If 3i Atlas represents observation from beyond our world, then humanity is experiencing that realization collectively for the first time, and how we respond will define us in ways we're only beginning to understand. Dr. Michael Sanders, a philosopher of science at Stanford, has been thinking deeply about the psychological and existential implications of confirmed observation by non-human intelligence. In a series of essays that have circulated among both scientific and philosophical communities, he explores what it means for humanity's self-conception when we realize we might be the observed rather than the observers. For all of human history, we've been the Watchers. We've looked at the stars and wondered if anyone looked back. We've searched for signals, sent our own messages, built radio telescopes and launched space probes. We've been the active agents in the search for cosmic intelligence, the seekers reaching out into an apparently empty void. But if 3I Atlas is a probe, if it represents observation from an older, more advanced civilization, then suddenly our role reverses. We're not the searchers, we're the found. We're not sending messages into darkness. We're receiving attention we never knew existed. We're not alone in the universe, and we never have been. Sanders suggests this realization would precipitate what he calls an existential role reversal that would affect human psychology at fundamental levels. Some implications: the loss of cosmic privacy. Everything humanity has done, our wars, our art, our scientific achievements, our moral failings, has potentially been observed and recorded. There's no taking back our history, no pretending we're better than we are. If we're being studied, then our observers have seen all of it: the beauty and the horror, the wisdom and the cruelty, the heights of human achievement and the depths of human savagery. This could be profoundly humbling, or profoundly shameful, or perhaps even liberating. If we're being observed by intelligence that has watched us throughout our development, perhaps they understand that species grow and mature, that early mistakes don't define ultimate potential. The end of human exceptionalism. For most of our history, humans have believed we're special, created in God's image, the pinnacle of evolution, the only conscious minds in the cosmos. Each scientific revolution has diminished this specialness. We're not at the center of the universe, not on the only planet, not even the only intelligent species on Earth, if we honestly assess the cognitive capabilities of other animals. But we've retained one last claim to exceptionalism. We're the only technological intelligence we know of, the only species that has reached for the stars. If 3I Atlas proves artificial, even that claim falls. We become one more emerging civilization among however many others exist across the galaxy. Common, not special, part of a larger pattern, not a unique occurrence. Some will find this crushing. Others will find it oddly comforting. We're not alone, not bearing the entire burden of being the universe's only conscious observers. The question of judgment. If we're being observed, are we being judged? Do our observers have opinions about whether humanity is worthy, ethical, promising, or dangerous? And more importantly, do those judgments carry consequences? This is where speculation becomes anxiety. If a sufficiently advanced civilization has been monitoring Earth and has concluded that humanity is dangerous, that we're violent, destructive, reckless with power, might they decide we need to be contained, controlled, or even prevented from developing interstellar capability? Sanders argues that this fear, while natural, might be unfounded. Any civilization capable of observing Earth across thousands or millions of years would have seen countless species emerge, develop intelligence, struggle with the challenges of technology and power. They would likely understand that aggression and conflict are common features of evolutionary history, not unique pathologies. More likely, Sanders suggests, is that observers would be curious rather than judgmental, scientific rather than moral in their assessment. They might want to know, how does this species solve the problems that all emerging technological civilizations face? How do they handle resource depletion, nuclear weapons, artificial intelligence, climate change? What solutions do they discover? What mistakes do they make? From this perspective, we're not being judged so much as studied, our experiences adding to a vast database of how intelligence develops and how civilizations navigate the treacherous path from planetary to spacefaring status. The transformation of meaning. Perhaps most profoundly, the realization of being observed changes what our actions mean. Every scientific achievement, every artistic creation, every moral choice potentially has an audience beyond humanity. We're not performing only for ourselves and our descendants. We're performing, whether we want to or not, for observers beyond our world. This could inspire us to be better, to aim higher in our achievements, to treat each other more ethically, to care for our planet more responsibly. The observer effect in psychology shows that people behave better when they know they're being watched. Perhaps civilization-scale observation would have a similar effect, but it could also be paralyzing. The anxiety of cosmic judgment might make us self-conscious, hesitant, afraid to make mistakes or take risks. And innovation requires the freedom to fail, to try things that might not work, to explore dead ends and learn from errors. To Rachel Kim at the University of Tokyo has been studying how different cultures respond psychologically to the possibility of extraterrestrial observation. Her research suggests that reactions divide roughly along existing cultural and religious lines. Some religious traditions are comfortable with observation. Their cosmologies already include observers, gods, spirits, ancestors, who watch human affairs and to whom humans are accountable. Adding extraterrestrial observers is simply expanding the community of witnesses, not fundamentally changing the nature of existence. Other traditions find extraterrestrial observation more threatening because it challenges fundamental assumptions about humanity's special relationship with the divine or humanity's unique role in the cosmos. Secular philosophies also split. Some find observation fascinating and welcome. Finally, we're part of a larger cosmic community. Others find it invasive and troubling. Our privacy as a species has been violated. Our development has been manipulated by observers with unknown motives. Kim suggests that the diversity of human responses is itself significant. It demonstrates that humanity is not a monoculture, that we contain within us many different perspectives on cosmic questions. If we are being observed, this diversity might be more interesting to observers than uniformity would be. They're not just watching humans, they're watching a species complex enough to disagree with itself about fundamental questions, including the question of what it means to be watched. Dr. Thomas Wright at Oxford has explored an even more subtle possibility. What if being observed is precisely the point? What if the purpose of probes like 3i Atlas is not just to gather information, but to create the experience of being observed, because that experience itself transforms species in crucial ways? Wright calls this the observer effect hypothesis, borrowing the term from quantum mechanics, where observation affects the system being observed. In this framework, the probe's mission is not just passive data collection, but active catalysis. Its presence, once detected, accelerates humanity's development, by forcing us to confront questions we might otherwise avoid. Questions like, are we ready for contact with alien intelligence? Have we achieved sufficient unity to speak for our species? Do we have wisdom to match our technology? Can we cooperate globally to respond to cosmic challenges? What do we want other civilizations to know about us? These are questions humanity needs to answer eventually, if we're to survive as a technological species and potentially join a galactic community. But they're easy to postpone indefinitely if there's no external pressure to address them. The presence of 3I Atlas, ambiguous enough to deny, suggestive enough to demand investigation, creates that pressure. It forces us to think seriously about contact scenarios, to establish protocols for responding to anomalous objects, to coordinate observations and analysis across nations and institutions. In doing so, we develop capabilities and frameworks that might prove essential if and when contact becomes undeniable. We're being prepared gradually and gently for a revelation that might otherwise be traumatic. Wright suggests this might be standard practice for advanced civilizations. Before revealing themselves directly, they create opportunities for emerging civilizations to prepare themselves psychologically, technologically, and socially for contact. The preparation itself becomes part of the contact protocol. From this perspective, 3I Atlas is not just observing us. It's teaching us, stretching us, inviting us to grow into a larger cosmic awareness at our own pace. Delisa Zhang has taken this idea in a different direction, suggesting that the observation might be bi-directional in ways we don't yet recognize. She proposes that by studying 3I Atlas, by bringing our instruments and analytical tools to bear on this mysterious object, we're simultaneously being studied by whatever intelligence launched it. The questions we ask reveal what we find important. The methods we use reveal our level of technological sophistication. The debates we have reveal our cultural divisions and philosophical assumptions. Our response to ambiguity reveals whether we're mature enough for cosmic citizenship or still too parochial, too quick to fear or worship anything we don't immediately understand. In other words, 3I Atlas might be a test, not in the sense of pass, fail, but in the sense of assessment. What stage of development has this civilization reached? What are their capabilities? What are their limitations? How do they handle uncertainty? How do they respond to potential contact? Our answers to these questions might determine what happens next. If we demonstrate scientific rigor, international cooperation, and psychological stability in dealing with this ambiguous object, perhaps more direct contact follows. If we respond with panic, wild speculation, and social fragmentation, perhaps the observers decide we need more time before further revelation. Zhang emphasizes that this is speculation, that we have no way of knowing if such an assessment is actually occurring. But the possibility is worth considering because it frames our response to 3I Atlas as meaningful, as potentially consequential, as something that matters beyond satisfying scientific curiosity. How we handle this mystery right now, in these months of investigation and debate, might be shaping the future of humanity's relationship with whatever lies beyond our world. As you drift towards sleep tonight, I want you to consider something that might seem strange at first, but becomes profound the longer you sit with it. What if the observation you feel sometimes, that sense that you're being watched, that your life matters beyond your immediate circumstances? What if that feeling has always been partially true? What if consciousness itself attracts attention in a universe where consciousness is rare? What if the very fact of being aware, of having subjective experience, of asking questions about existence makes you matter to something larger than yourself? This is not provable, not scientific in the usual sense, but neither is it dismissible. In a cosmos where intelligence has emerged at least once, us, and possibly countless other times, them, the question of whether consciousness attracts observation is not absurd. It's a genuine question about the nature of a universe that has organized itself in ways that permit observers to exist. So sleep tonight, knowing that whether or not 3i Atlas is watching, whether or not we're part of some vast cosmic study, your existence is meaningful. Your consciousness, your capacity to wonder, your ability to ask questions about stars and space, and whether anyone is watching, these are not trivial accidents. They're fundamental features of a universe that, mysteriously, has arranged itself in ways that permit matter to become aware of itself, to look up at the stars, and to ask if anyone is looking back. And if someone is looking back, if we are being seen by intelligence beyond our world, then perhaps the most important thing we can do is to be worth watching, to strive for wisdom, to treat each other with compassion, to care for our world, to reach for understanding rather than fear. Because what we're observed doing, what patterns we create, what story we tell through our actions, that might be our first and most important message to whatever or whoever is paying attention. Sleep well, knowing you're part of that story, that your life contributes to the pattern humanity is creating, that you are both observer and observed in a cosmos far more conscious than we ever imagined. We've journeyed together through mathematical improbabilities and spectroscopic anomalies, through hypotheses about memory and theories about communication, through questions about observation and speculation about intention. We've explored what 3i Atlas might be, what it might mean, and what its presence in our solar system could reveal about humanity's place in a cosmos that may be far more alive with intelligence than our telescopes have yet confirmed. But I want to end not with answers, but with the beauty of enduring mystery. Because the truth is, we don't yet know what 3i Atlas represents. We may not know for months or years. We might never know with certainty. And there's something profound in that uncertainty, something valuable in living with questions that can't be immediately resolved. In our age of instant information, where answers are always just a search away, we've forgotten how to sit with mystery, how to let questions breathe and develop rather than demanding immediate resolution. 3i Atlas invites us to remember that skill. It asks us to hold multiple possibilities simultaneously, natural and artificial, chance and intention, coincidence and design. It asks us to remain open to evidence while maintaining skepticism, to take observations seriously while resisting premature conclusions. This is what good science looks like. Not the cartoon version, where researchers immediately know what everything means, but the real version where ambiguous data requires careful analysis, where interpretations are debated, where honest scientists can look at the same evidence and reach different conclusions. Whatever 3i Atlas proves to be, and we will eventually have better data, clearer evidence, more definitive answers, it has already accomplished something remarkable. It has reminded us that the universe still holds surprises, that the cosmos is not yet fully catalogued and explained, that there are still mysteries waiting just beyond our instrument's reach. For those of you who find this thought comforting, who love the idea that the universe remains strange and wonderful, 3 Atlas is a gift. It's permission to keep wondering, to keep looking up at the stars, to keep asking questions that might not have immediate answers. For those who find uncertainty troubling, who prefer clear answers and defined categories, 3i Atlas is a different kind of gift. It's an invitation to develop comfort with ambiguity, to recognize that not all questions can be resolved quickly, that some of the most important discoveries require patience and tolerance for not knowing. Either way, 3i Atlas has expanded our imagination about what's possible. It has forced us to think seriously about scenarios we might otherwise have dismissed as science fiction. It has demonstrated that the boundary between natural and artificial, between chance and design, between cosmic accident and intentional visit is far less clear than we typically assume. And perhaps most importantly, it has united humanity, at least within the scientific community, in a shared project of investigation. Observatories around the world have coordinated observations. Researchers across disciplines have collaborated on analysis. Data has been shared freely. Papers have been published. Debates have been conducted with scientific rigor and mutual respect. In a world that often feels fractured by conflict and division, this global collaboration around a cosmic mystery offers a glimpse of what humanity can accomplish when we work together toward understanding, rather than allowing fear or ideology to divide us. If 3i Atlas is indeed a probe from another civilization, if it's observing our response to its presence, then this collaboration is perhaps the most important thing it could observe about us. Not our technological capability alone, but our capacity for cooperation, our commitment to rational inquiry, our willingness to put aside differences in pursuit of knowledge. That's the species we want to present to the cosmos. Not perfect, not without flaws, but capable of working together, of learning, of growing, of rising to meet challenges with curiosity rather than fear. As you drift into sleep tonight, under the same stars that have guided human wonder for countless generations, I want you to know that you're living through a remarkable moment. Whether 3i Atlas proves to be a natural interstellar comet or something far stranger, whether our current interpretations hold up or collapse under further scrutiny, whether contact is coming or remains forever distant, regardless of how these questions resolve, you are alive at a time when humanity seriously considers the possibility that we are not alone. That consideration itself changes us. It expands our awareness of cosmic possibilities. It invites us to think beyond our immediate concerns and local conflicts. It reminds us that Earth is not the whole universe, that our species is not the end of evolution, that consciousness itself might be a far more common and varied phenomenon than we've allowed ourselves to believe. So sleep well tonight, knowing that somewhere in the darkness above us, 3i Atlas continues its ancient journey through our solar system, whether it carries instruments that watch and record, whether it transmits data back to distant civilizations, whether it's aware of our attention or indifferent to our fascination, These questions remain open, but in the space of that openness, in the pregnant possibility of mystery not yet resolved, we find something precious: wonder, the capacity to be amazed, to be humbled, to recognize that despite all we've learned, the universe still has secrets, still has surprises, still has depths we've barely begun to explore. And wonder, that sense of profound curiosity mixed with reverence, might be the most valuable thing we possess. It's what drives science, what inspires art, what connects us to something larger than ourselves. It's what makes us not just conscious, but consciously aware of the vast cosmos that contains us. 3 Atlas, whatever it ultimately proves to be, has given us the gift of renewed wonder. For that alone, we should be grateful for its passage through our small corner of the galaxy, grateful for the questions it raises, grateful for the reminder that we live in a universe far stranger and more beautiful than we have yet learned to imagine. Thank you for joining me on this journey through cosmic possibilities. If this exploration has sparked your curiosity or brought you some measure of peace before sleep, I would be honored if you would like this video and subscribe to our channel. Your support allows us to continue creating content that makes the mysteries of the cosmos accessible and fascinating for everyone who shares our sense of wonder. Remember that while we've explored many speculative scenarios tonight, the scientific investigation of 3I Atlas continues. Real researchers around the world are gathering data, testing hypotheses, and working to understand this remarkable object using the rigorous methods of science. The truth, whatever it proves to be, will emerge from that careful work rather than from speculation or wishful thinking. Share your thoughts in the comments below. Tell us where you're listening from, what time it is in your corner of this small blue world, and which of tonight's possibilities you found most intriguing or most unsettling. Your perspectives and questions help shape our future explorations and remind us that the search for understanding is always a collaborative endeavor. Until we meet again under the gentle light of distant stars, may your dreams be filled with wonder and your rest be peaceful. We live in a remarkable universe, and the fact that we can contemplate its mysteries, that we can ask questions about cosmic visitors and alien intelligence, that we can wonder about our place in the vast scheme of things, that capacity for wonder is itself miraculous. Sleep well, fellow travelers. Tomorrow the stars will still be there, waiting for us to look up and wonder what secrets they hold. And 3I Atlas will still be there, silent and mysterious, inviting us to keep asking questions even when answers are slow to arrive. Good night and clear skies to you all.